Hello everyone, we are now going to go over the lymph node flow cytometry from a 46-year-old woman who presented with enlarged cervical and axillary lymph nodes. So this is the lymph node biopsy, so we expect majority of our cells to be lymphocytes. And here we see that it's a CD19 versus site scatter plot. We did not give you the CD45 versus site scatter, instead we gave you 19 versus site scatter. And here we see that in CD19, we have a population that is distinctly brightly positive for CD19, and it's painted in two different colors that are kind of mingled with each other. One is red and other is green. And there is a population that has variable CD19, dim, and even there is something that is negative. But it's the same population with a spectrum of expression of CD19. And here we have some granulocytes with high site scatter and maybe some monocytes in the background. Now, when we go to kappa versus lambda, we can see that these 19 positive cells that are red and green, that those colors are coming from here. So the lambda positive B cells are painted green and the kappa positive are painted red. So these are the normal background polyclonal B cells, and our aqua population here that has the variable CD19, we see that those are also kappa restricted. They express kappa. There is nothing here in lambda. They are kappa restricted. And these 19 positive B cells are negative for CD5. And in CD38, we see a subset that is positive for CD38. And this is also the subset that is completely negative for CD19. And all our B cells are negative for CD10, including the neoplastic ones. And a subset of this aqua population is positive for CD200, and this is also negative for CD19. And here we see in CD20, there is a variable expression of CD20, and our 19 negative cells also express CD20, and the 19 positive cells also express CD20. So we have B cells that have variable expression of CD19 and CD38, and they are positive for, there's a subset that is positive for CD200. Now we have to remember that plasma cells aberrantly can express CD20. So that is something to keep in mind, but we'll discuss detailing about that later. And again, our B cells are all negative for CD5, I mean the neoplastic cells. And in CD38, you just see a spray of cells that are positive, 10 negative. They are again kappa restricted. Here we can nicely see, here it is kind of buried behind the polyclonal kappa cells. Here you can see them clearly. So the kappa polyclonal normal background kappa cells are here that are red, and your aqua population is also kappa. And the lambda positive cells are green here, and you don't see anything in green in that normal population. Now, in the first tube, we saw that there is a population of expressing variable CD19 and kappa restricted, and it expresses CD20, and a subset expresses CD38 and CD200. So now aberrant plasma cells and B cells can exist together. And this is something that is suspicious for that kind of a picture, because you have a CD38 positive CD19 negative population, which can be seen in neoplastic plasma cells. Normal plasma cells are positive for CD19, but neoplastic plasma cells lose CD19, and they can aberrantly express CD20 also. So that is something suspicious. So we added our plasma cell tube. And one more thing that you have to remember is aberrant expression of CD200 is common in neoplastic plasma cells also. So here we see site scatter versus CD38. So they just gated the CD38 positive cells, and they saw that those cells have variable expression of CD138 also, and those are the cells that are negative for CD19. Here we see the polyclonal CD19 positive cells in the background, and they are kappa restricted, and they don't express CD117. They again show loss of CD19. They do not express CD56. They show loss of CD27, CD200 is positive. So neoplastic plasma cells lose CD19, and they can express CD117 and CD56 apparently, and they can also express CD200 apparently, which we see here. Neoplastic plasma cells usually lose CD45 and CD27. We see loss of CD27 here. 45 is still pretty bright here, which is kind of unusual. And so here in this case, we see a B cell population that is here 19 and 20 positive, which is kappa restricted, and a plasma cell population that is also kappa restricted and has apparent expression of CD200 and loss of CD27 and loss of CD90. So in this raises the differential of maybe a lymphoplasmacytic lymphoma or a marginal zone lymphoma with plasmacytic differentiation. So we don't know. We cannot say that from flow cytometry. That needs extensive testing. Even if you see that in the tissue, you would need molecular testing like MYD88 to see if it is LPL or serology, if there is a Waldenstrom's like picture, IgM expression, IgM monoclonal bands in your SPEPs. All of these are needed to determine whether this is an LPL or lymphoplasmacytic lymphoma or a marginal zone lymphoma with plasmacytic differentiation. From flow, you can only say what is the percentage of aberrant kappa restricted B cell population that you see, and certain percentage of apparent kappa restricted plasma cell population that you see, and you can describe what aberrancies you see. For example, in this one, you have 5 negative, 10 negative B cells, and you have the plasma cells that show apparent expression of CD200 and show loss of CD27 and 19. So that's all you will say in your report. Other thing that you have to keep in mind is plasma cells are often underestimated by flow because they are lost during processing. And also this is, we do surface light chain expression for light chain analysis for B cells, but we do cytoplasmic light chain analysis for plasma cells, and there is extra step of lysing, and the plasma cells are again lost there too. So never rely on the number that we get from flow cytometry for plasma cells. In general, do not rely on that number for anything, but especially for plasma cells, they are often underestimated. So this one, the final diagnosis turned out to be LPL, that is lymphoplasmacytic lymphoma, but that was not made on flow cytometer. So your top line here would be just the percentage of aberrant B cells and the percentage of plasma cells. And you can discuss the differential diagnosis in your comment. Thank you.